Hello there, and welcome back to the Sleep Science. Tonight, you're floating somewhere impossibly far back in time, before starlight, before structure, before anything you'd recognise as a sky. There's no up or down, no colour, not even the comfort of a single photon brushing your skin. It's just you and the afterglow of creation, a cooling haze of hydrogen and helium that hums softly like the world's first lullaby. You probably won't survive this. Well, mostly because technically you don't exist yet, but don't let that ruin the mood. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop your location and local time in the comments, because I love seeing where in the universe you're tuning in from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift through the ancient dark, roughly 380,000 years after the Big Bang, a blink in cosmic terms, but already the chaos of that first explosive instant has calmed into something gentler. The universe, once opaque and blindingly hot, has finally cooled enough for atoms to form, releasing a faint cosmic microwave whisper that still lingers even now. Everywhere you look, space is calm, almost eerily so. There are no galaxies, no stars, not even dust, just hydrogen, helium, and the faint signature of potential. It's a weird kind of peace, the sort that feels like the moment right before a city wakes up. You can almost sense the tension in the silence, the gravitational pull of the future hidden in every atom. If you could listen closely enough, you might hear the soft murmur of density fluctuations, those tiny irregularities seeded in the Big Bang itself. Some regions are ever so slightly thicker than others, and it's from those humble wrinkles that everything, literally everything, will someday bloom. A historical note floats by in the darkness. It was in the mid-20th century that astronomers like George Gamow and Ralph Alpha began piecing together the idea that this early universe once glowed with primordial light. Their calculations predicted the cosmic microwave background decades before it was accidentally discovered in 1965 by Penzias and Wilson, who, by the way, thought their radio antenna was just full of pigeon poop. The pigeons were evicted, the Nobel Prize stayed. You drift past that invisible hum of leftover radiation, the oldest light you can ever see, stretching thinner and cooler with every cosmic breath. It's a strange comfort that the universe began in such simplicity. Everything familiar, planets, stars, and your favourite questionable snack foods, will eventually come from this silent fog. But for now, it's a dark expanse of almost nothing. A blank canvas on which gravity is quietly sharpening its brush. Out here, time feels syrupy. 1,000,000 years might pass while you blink, though there's nothing yet to measure it against. The first light is still hundreds of millions of years away. You're surrounded by potential energy waiting to topple like the first domino. Somewhere, maybe, a slightly denser patch of gas is beginning to stir, ever so slightly, under its own weight. That's where galaxies will someday be born. Not from explosions, but from the gentlest tug-of-war between matter and emptiness. And here comes the first quirky tidbit of the night. Technically, the universe at this stage is too dark even for blackness. There's not enough visible light to define contrast, so dark doesn't quite mean what it means to you. It's more like swimming in an endless, evenly grey fog, a place where direction and distance dissolve together. If you've ever stared at a blank computer screen and wondered where to begin, congratulations. You've shared the universe's first existential crisis. Historians, well, cosmologists really, still argue whether calling this era the Dark Ages is a bit dramatic. After all, it wasn't completely devoid of light, just of visible light. The glow of the cosmic background was still there, just red-shifted into invisibility. But humans do love their poetic labels, and the slightly warm infrared epoch doesn't exactly sound bedtime story ready. As you float, you notice faint ripples growing a little denser, guided by invisible scaffolding, dark matter. It's already there, silent and unseeable, tugging on the gas like a patient gardener arranging seeds. The visible universe will simply follow its shape later, the way frost follows the pattern of a window pane. You reach out, but of course your hand, if you even had one, passes through without resistance. It's like trying to grasp a thought mid-dream. If this all feels slow, that's because it is. Galactic birth is not a fireworks show. It's more like cosmic sourdough, taking its sweet time to rise. But that's part of the magic. You're watching the universe in its most introspective state, resting after its fiery creation, collecting itself before the next act. There's a soft humility in that, a kind of cosmic deep breath. And if you squint your imagination, you can almost sense how this emptiness will someday teem with everything. Stars pulsing, galaxies colliding, black holes humming lullabies of destruction and creation, all from this still, quiet beginning. For now, though, let it be silent. The hydrogen waits, gravity hums, and you, somehow, float between the seconds, watching the birth pains of the cosmos not yet begun. You could almost fall asleep here, lulled by the soft expansion of space itself, stretching you gently in every direction. Don't worry, you'll wake up in the next section, just in time for the first whispers of gravity to start their slow, inevitable persuasion. You open your eyes, or at least whatever passes for eyes in this void, and the silence has changed. It's still vast and gentle, but there's a hint of movement now, a subtle stirring under the surface of nothing. Gravity, the universe's quiet persuader, is beginning its long, patient work. You can't hear it exactly, but you can feel it, an almost musical vibration, low and slow, as invisible threads of attraction start pulling matter together. Hydrogen atoms that once drifted lazily are now nudging closer, clustering into faint wisps. They don't rush. They're like shy party guests inching toward one another at a painfully slow mixer, realizing that together they might form something worth remembering. You drift among them, sensing the tension build, a sort of soft cosmic choreography unfolding in the dark. You might imagine gravity as the universe's first artist. Its tools are simple: attraction, patience, and time. No paintbrush, no melody, no grand explosion, just a steady insistence that everything likes to gather. Those tiny fluctuations left over from the Big Bang, the denser specks of hydrogen and helium, start tugging on nearby matter. A little bit becomes a little more, and soon these ripples grow into clumps, the seeds of what will become galaxies. There's a fact for you to keep. This process took hundreds of millions of years. By the time the first true galaxies appear, the universe will be nearly 500 million years old. That's a long gestation period, even for something cosmic. Still, gravity never rushes. It has forever to get things right. The quirky tidbit of this section: if you could somehow see gravity working right now, you'd notice that its reach is absolutely ridiculous. Even as atoms cluster here, their faint pull extends across light years. Imagine every particle holding hands with trillions of others, each whispering, "Come closer." It's like the world's slowest group hug, where no one ever lets go. Historians, or rather physicists, still argue whether gravity alone could have pulled this off without help from dark matter. Some suggest that visible matter was simply too sparse and too gentle to gather on its own. Others believe dark matter's invisible web was the real instigator, guiding everything into place. The debate lingers, partly because we can't see dark matter directly, only its gravitational fingerprints. It's like trying to solve a mystery when your main suspect is made entirely of shadows. Still, the evidence is mounting. Simulations show that dark matter formed an invisible skeleton across the cosmos, a vast web where galaxies would later grow like dewdrops on silk. And right now, in this moment, you're floating through one of those invisible intersections, a gravitational crossroad where the first faint knots of structure are forming. You drift closer to one of these embryonic clumps, and it looks nothing like the bright galaxies you know. It's a faint translucent cloud, so diffuse you could fly through it without noticing, if you had a ship, that is. The gas isn't hot or glowing yet. It's still whisper cold, hovering just above absolute zero. But something is happening deep inside. The center is getting slightly denser, slightly warmer, as gravity squeezes the atoms closer. It's like watching a candle being imagined before it's lit. You can almost picture the math happening around you, forces balancing, densities rising, energy spreading like ripples in syrup. There's a rhythm to it, a cosmic tempo that never misses a beat. And as the first proto-galactic clouds begin to form, you start to sense the faint prelude to the stars themselves. The gas is falling inward, swirling slowly, creating turbulence that will eventually ignite fusion. If the early universe had a soundtrack, this would be its ambient intro. No drums, no melody, just a deep pulsing hum of inevitability. Somewhere, light is preparing to exist again. There's something comforting in the idea that gravity never stops persuading. Even now, billions of years later, it's still at it, keeping planets tethered to stars, stars bound in galaxies, galaxies bound in clusters. Without it, everything would just drift apart into cold isolation. But with it, the universe has shape, purpose, and just the right amount of tension to make things interesting. And speaking of interesting, did you know that Einstein himself didn't entirely trust gravity at first? Well, not in the cosmic sense. His equations in 1915 predicted an expanding universe, but that seemed absurd to him, so he added what he called the cosmological constant to hold things steady. When later evidence showed the universe was expanding after all, Einstein reportedly called that constant his greatest blunder. Though between you and me, modern cosmologists revived the idea anyway under a new name, dark energy. So maybe it wasn't such a blunder after all. You watch as more clumps form across the endless dark. Some grow large enough to attract others, merging like droplets on a leaf. Each collision adds energy, heat, and complexity. The universe is no longer quiet, it's beginning to hum with potential, even if no one's around to hear it. If you could taste the air here, not that there is air, it would be thin, metallic, and utterly still. Time feels syrupy again, stretching long and lazy. You've been watching for what feels like minutes, but out there, hundreds of millions of years have passed. The universe is patient, and you're learning to be too. You float a little farther back, taking in the grand view. The once smooth fog of hydrogen and helium now ripples like ocean waves, full of texture and promise. Everywhere you look, gravity's fingerprints are visible. Delicate swirls and tendrils, faint outlines of future galaxies. You can almost see the Milky Way's earliest ancestor forming out there, a dim haze of gas that one day will host spiral arms, supernovas, and perhaps a small blue planet with creatures who look up and wonder how it all began. You smile, or maybe the void smiles through you. It's hard to tell. Either way, the universe has taken its first real step toward beauty. Gravity has whispered, and the hydrogen has listened. Soon, very soon, those whispers will turn into fire. You don't notice the exact moment when silence turns into sound, or darkness into shimmer. It's subtle at first, a faint spark, a flash of energy inside one of those dense clouds you've been following. The atoms there, fallen so far inward, press so tightly together that their nuclei can't resist anymore. They fuse, and in that instant the universe opens its eyes. A star is born. It's not alone for long. Across the young cosmos, other pockets of gas do the same, lighting up like scattered campfires in a dark desert. For the first time since creation, the universe glows, not with the leftover light of the Big Bang, but with something new, self-made, deliberate. You feel the warmth, faint but unmistakable, washing over you in slow waves. These are the first sparks of light, the cosmic dawn. You drift closer to one of these newborn stars, a brilliant blue giant that would make the sun look like a candle stub. It hums with energy, burning hydrogen at a ferocious rate, living fast and bright because it doesn't know how to do anything else. Around it, smaller stars flicker into existence, their gravity weaving them into families, clusters, the beginnings of what might someday be called galaxies. The darkness isn't gone yet, it's just learning to share. Here's your historical anchor. In 1990, the Hubble Space Telescope launched and gave humanity its first clear view of ancient starlight. By peering deeper into space, and thus further back in time, Hubble captured snapshots of this very era, the moment when the first stars began to pierce the darkness. It was like looking through the universe's baby photos. Those fuzzy red smudges, once thought to be artifacts, were actually galaxies so distant their light had travelled for more than 13 billion years. Humanity, it turned out, had built a time machine with mirrors. As you drift through these fiery newborns, the space between them is still thick with hydrogen gas. Every photon of light must fight its way through a fog of neutral atoms that scatter it like mist. The universe hasn't yet become transparent again. These first stars are the ones who will make that happen. Their light, fierce and ultraviolet, begins to ionize the gas around them, breaking atoms apart, clearing pockets of transparency. The fog starts to lift. You could think of it like cosmic morning. the sun rising slowly, burning away the mist that's clung to the hills. Only here, the hills are clusters of dark matter, and the mist is the very fabric of the early universe. But there's something heartbreakingly short-lived about these first stars. They're massive, hundreds of times heavier than the sun, and that means their lives are fast and furious. Within just a few million years, they collapse and explode as supernovae, scattering the first heavy elements, carbon, oxygen, iron, into space. The universe, once made of only hydrogen and helium, now has the ingredients for everything more complicated. Planets, people, and pineapple pizza, if you must. Here's your quirky tidbit. These first-generation stars, known as population 3 stars, have never been directly observed. Not one. They're long gone, their ashes mixed into later generations. Astronomers are still hunting their signatures in distant galaxies, like detectives searching for DNA evidence from a crime billions of years old. When they do find one, it'll be like hearing the universe's very first heartbeat replayed across time. Historians and astrophysicists still argue whether these first stars formed alone or in small clusters. Some models suggest they appeared one by one, isolated in vast clouds of gas. Others think they came in tight groups, their radiation shaping one another's growth like competitive siblings. The truth may be somewhere in between, but the debate keeps telescopes pointed upward, chasing answers written in light. You drift closer to one of the newborn clusters. The light here is searing, almost liquid. The gas around the stars glows pink and gold, stirred by radiation pressure. It's beautiful but deadly. No place for fragile things. The first elements forged inside these stars are just beginning to escape, carried outward by stellar winds. You can almost see the metallic glitter of oxygen and carbon dust swirling like cosmic pollen. A few supernovae have already gone off nearby. You can sense the shockwaves rippling through the gas, compressing nearby clouds, triggering more star formation. It's a chain reaction. Stars beget stars. Galaxies, though not yet formed, are being sketched in starlight. The universe is learning how to make itself interesting. You pause for a moment, floating between two of these luminous knots. The light is almost too pure to look at, sharp and unfiltered. You realize how young it all is, how new. Every photon here is a pioneer, the first to cross space unchallenged. It feels sacred, in a way that makes you lower your non-existent voice. Down below, gravity continues its patient persuasion, drawing these clusters closer together. The stars you see now will soon swirl into larger structures, proto-galaxies, each with its own destiny. But for this brief moment before things get tangled and messy, the cosmos is pure wonder, tiny islands of light adrift in infinite shadow. If you could take a selfie here, and hey, you deserve one, it would look surreal. A faint silhouette against a backdrop of the universe's first fireworks. You'd caption it something like, "Just hanging out at 13.5 billion years ago, NBD." But deep inside you'd feel it. The gravity, the heat, the pull toward creation. This isn't just light filling the void. It's the first evidence that the universe remembers how to make beauty. You float back, watching the newborn stars burn, their light spilling outward like spilled ink in reverse, bright instead of dark, creative instead of destructive. You can already sense how their ashes will one day form new generations, how galaxies will bloom from their remains, but that's still to come. For now, enjoy the shimmer, the slow unfurling of the cosmos as it teaches itself to glow. Because once the first light appears, the darkness will never truly return. The newborn stars flicker in clusters now, thickening into clouds so large they seem to breathe, slow, steady, like lungs of the cosmos inhaling gas and exhaling light. You drift through one such cloud, a billowing mass of hydrogen and helium so vast it could swallow 1,000,000 solar systems without noticing. It's warm near the center, but the edges are still icy, shivering in the dark. The whole thing hums, alive with motion. You can feel it in your bones, or whatever passes for bones when you're starlight adjacent. The cloud is collapsing, but not all at once. Some parts give way faster, tumbling inward under gravity's soft insistence, while others resist, buoyed by turbulence and magnetic ripples. You realize you're inside the nursery of a future galaxy, a proto-galaxy to be precise. Not quite a spiral or an ellipse, not yet anything recognizable, just a glorious mess of gas, dust, and radiant confusion. It's beautiful though, in a chaotic, probably going to explode kind of way. You watch as one region glows brighter, then dimmer, like the universe learning to breathe on its own. It's fire without flame, energy without form. This is where galaxies begin, not as perfect pinwheels of stars, but as collapsing clouds fighting themselves into existence. The same basic ingredients, gas, gravity, time, will make every galaxy you'll ever know. It's cosmic minimalism at its finest. Here's your historical tidbit. In the 1950s and 60s, astronomers like Alan Sandage began mapping nearby galaxies and realized something startling. They seemed to evolve in shape. Spirals, ellipticals, irregulars. Each type wasn't just a random design choice, but a clue to a galaxy's age and environment. The famous Hubble tuning fork diagram, first sketched by Edwin Hubble himself, became a kind of cosmic genealogy chart. Every smudge of light in the sky had a history, a lineage, a process. The universe, it turned out, was full of family drama. Back in this early epoch, though, there's no order yet, just the rehearsal. Clouds merge and fragment, slammed by gravity and radiation from nearby supernova. Some regions spin faster, flattening into disks. Others puff up into rough spheroids. The proto-galaxy around you looks like a glowing jellyfish, its arms waving through the void. And here's the quirky bit. Scientists think some of these early proto-galaxies might have formed stars so quickly they burned themselves out in less than 1 billion years. Imagine an entire galaxy as a cosmic teenager. Brilliant, intense, emotional, and completely unsustainable. Historians, well, astrophysicists, still argue whether that early frenzy was triggered by rapid gas inflows, or if dark matter halos simply trapped so much material that star formation became inevitable. Either way, the result was a brief but spectacular light show. You float closer to a dense knot in the cloud. The gas is swirling faster now, spiraling inward like cream in coffee. The pressure builds and suddenly, snap, a new burst of star formation ignites. You can feel the shockwave roll through the gas, lighting up the surrounding material in waves of colour. Soft pinks, electric blues, ghostly greens. It's a light show with no audience except you. Everywhere you look, creation is messy. Stars form, live, and die in short, furious lives. The first supernovae send ripples through the gas, compressing it here, clearing it there. You realize you're watching the universe's first feedback loop, destruction creating more creation. One explosion gives birth to 10 more stars. The proto-galaxy is learning to self-regulate, a chaotic orchestra tuning its instruments before the first real symphony. At the same time, small galaxies begin to merge into larger ones. You catch a glimpse of 2 nearby proto-galaxies drifting toward each other, their gaseous halos touching first, then tangling. When they collide, the stars themselves won't crash, space is too big for that. But their gas will mix and ignite, triggering a fresh burst of star formation. You can almost hear the hiss and hum of the collision, like waves meeting in slow motion. The result is breathtaking. A new, larger galaxy, hotter, brighter, more organized. Every merger adds complexity, every collapse adds shape. The universe is sculpting itself through collisions, learning the art of balance through chaos. You drift along one of the tendrils of this cloud, tracing its glowing filaments. They stretch for light years, feeding the core with new material. The process reminds you of lightning frozen in time, a luminous branching pattern shaped by invisible forces. You reach out to touch it, and your fingers pass through, leaving ripples in the starlight. For a moment, you wonder if galaxies feel their formation, if somewhere in that swirling gas there's a sense of purpose, of becoming. Probably not, but you can't help feeling it yourself. Watching a galaxy being born is like seeing a thought form in slow motion. It's chaos with intent. Here's a quiet truth. Not all clouds succeed. Many collapse too quickly and burn out before reaching galactic maturity. Some get torn apart by early supernovae, never forming coherent structures at all. Even in the cosmic nursery, failure is part of the design. But gravity doesn't give up. Every fragment becomes raw material for the next attempt. The universe keeps trying until something works. You hover above the proto-galaxy now, looking down. The view is mesmerizing. Bright knots of light scattered through a smoky halo, arcs of glowing gas tracing invisible gravitational wells. The cloud doesn't look quiet anymore. It looks alive, and you can't help but think of something familiar. Galaxies are just like ideas. They start as faint whispers in the dark, tiny instabilities that grow with attention and time. They pull in surrounding thoughts, merge with others, collapse under pressure, and if they survive, shine. The proto-galaxy around you exhales again. One last wave of radiation ripples outward, a shimmering sigh. You close your eyes, feeling it wash over you, the warmth of creation brushing past. When you open them again, the gas has thinned, the light has softened. The chaotic clouds have begun to settle into shape. The first true galaxies are forming. The universe, finally, is awake. You drift higher above the glowing proto-galaxies, and the view suddenly shifts from local chaos to a breathtaking, ordered vastness. The individual clouds, which once seemed to dance alone, are now part of something far larger. Threads of light and shadow stretching in every direction, weaving the cosmos into a grand lattice. This is the cosmic web, the hidden skeleton of the universe unfurling before your sleepy eyes. It's a network made not of stars or gas, but of gravity itself. Dark matter, that unseen architect, has spun its invisible threads across the cosmos, forming filaments that link galaxies together like pearls on strings. Between them lie yawning voids, cosmic deserts where matter is scarce, where silence reigns. The structure stretches for billions of light years, but from where you hover, it looks almost delicate, like spun sugar in endless night. You float closer to one of the filaments. Though you can't see dark matter directly, you sense it as a gentle tug beneath your feet, shaping the path of ordinary matter around it. Gas flows along these gravitational highways, funneling toward the dense intersections where galaxies cluster. It's mesmerizing, like watching rivers of starlight carve their way through the void. Your historical touchstone drifts into view. Back in 1989, astronomer Margaret Geller and her colleague John Huckra released the first three-dimensional map of the nearby universe. It revealed an astonishing truth. Galaxies weren't scattered randomly, but arranged in vast walls and filaments, the beginnings of the cosmic web we see today. Their discovery reshaped cosmology almost overnight. The universe, it turned out, was less like a soup and more like a sponge, dense veins surrounded by great emptiness. Now you see it playing out in real time, though real time here means millions of years per blink. Streams of gas slide along dark matter filaments toward the nodes where proto-galaxies wait. They merge, ignite, and grow brighter, feeding off the flow like glowing coral along invisible reefs. You can almost imagine the hum of it all, a cosmic circulation system, steady and endless. Here's your quirky tidbit for the night. Computer simulations suggest that if you could somehow shrink yourself down to the scale of a galaxy and then listen, the cosmic web might actually vibrate. Not in a musical sense, sorry, no cosmic jazz yet, but as slow oscillations, massive low-frequency ripples as matter shifts along the filaments. If you could hear it, it would be the deepest possible bass note, one that takes millions of years to play a single beat. You follow one glowing thread across the darkness, drifting between embryonic galaxies. The filament stretches so far that perspective itself seems to warp. You can't tell where it begins or ends. Every few 100,000 light years, another galaxy glimmers to life, born from gas drawn along the same unseen pipeline. They are family, siblings sharing a gravitational ancestry, all feeding from the same stream. Historians of science still argue whether this web formed purely under the influence of dark matter, or whether ordinary baryonic physics, cooling gas, radiation, turbulence, played a stronger role than simulations suggest. Some say the web was pre-written in the universe's earliest density ripples. Others claim it evolved later through feedback from galaxies themselves. Either way, the debate continues, and the web only grows more intricate the deeper we look. You notice something else now. The filaments are not static. They pulse. Gas flows inward. Stars light up. Galaxies migrate slowly along the strands. Over billions of years, clusters at the intersections grow massive, pulling smaller galaxies toward them. Even emptiness, it seems, has direction. You decide to drift toward one of these intersections, a node glowing brighter than the rest. As you approach, you realize it's not a single galaxy, but hundreds of them, bound together by gravity in a communal swirl. The space between them buzzes with energy. Jets from black holes burst from supernovae, the silent roar of intergalactic winds. Yet from afar, the cluster looks tranquil, like a lantern floating in a dark sea. The closer you get, the more obvious it becomes that this web isn't just structure, it's a map of motion. Matter flows along its filaments like traffic through a cosmic city grid. The voids, those vast dark gaps, act as quiet suburbs, while the intersections pulse like downtown cores. You can't help but smile. Even the universe seems to prefer a little urban planning. Everywhere, faint trails of light mark the journeys of wandering galaxies, tiny sparks migrating from one filament to another. Some are drawn into clusters and devoured, others drift into solitude, fading into the background hum. There's an almost biological rhythm to it, as if you're watching the circulatory system of some colossal breathing organism. You pause and turn, looking back at the network behind you. It goes on forever. Patterns within patterns, threads looping into webs, webs weaving into sheets. It's dizzying, but also comforting. The universe, so often thought of as empty, is actually connected in ways deeper than sight. And here's a little sleepy thought to take with you. Every galaxy you'll ever know, including the Milky Way, is just one glowing bead on this infinite thread. Your home sits tucked into a small filament, orbiting quietly, drifting through the dark on a gravitational breeze. When you look up at the night sky, you're really peering along the same filaments you're floating through now, though you'll never see them directly. The cosmic web stretches onward, patient and eternal. You follow it a while longer, tracing its gentle arcs until the filaments begin to knot tighter, the clusters brighter. The intersections are thickening with galaxies swirling closer together. Something larger is brewing, an era of galactic encounters, collisions and growing pains. You can already feel the shift in the current, a faint gravitational pull ahead. The cosmic web has guided the universe this far, but soon it will give rise to something new, the grand ballet of merging galaxies. For now, though, you drift along the filament's glowing edge, lulled by the quiet vibration of the web, the universe's first great symphony of structure. You let the soundless rhythm carry you forward, knowing that where these threads meet, galaxies will learn to dance. You follow one of those filaments until it widens into a soft halo of light. It looks peaceful from afar, almost sleepy, like a fog bank at dawn. But as you glide closer, you realize it's anything but calm. Two young galaxies are drifting toward each other, slow by human standards but at cosmic scale. It's a full-blown traffic accident in progress. The universe has entered its collision phase. The galaxies are roughly the same size, each a few billion stars strong. Their gas halos overlap first, whispering before the stars even touch. Gravity grabs hold, and suddenly everything changes. The spirals warp and stretch. Long tails of glowing gas fling outward like ribbons in a zero-gravity breeze. You can hear it in your imagination. No sound, but a rising pressure, a deep thrumming pulse as the two begin their dance. You hover near the edge of one disk and watch its arms twist into tidal streams, great bridges of stars flung across space. Some of those stars will be cast into the intergalactic void forever, lone wanderers without a home galaxy. Others will fall inward, feeding a burst of new star formation at the merging cores. Collisions, it turns out, don't just destroy, they create. It's easy to think of galaxies as fragile snowflakes, but they're astonishingly resilient. Even in the thick of this slow-motion crash, most stars pass each other unharmed. The space between them is so vast that direct impacts are rare. Instead, it's the gas that feels the shock, compressed, heated, and ignited into fresh star nurseries. You're watching a galactic recycling program at work. Your historical tether arrives in a swirl of cosmic dust. In 1926, Edwin Hubble used the 100-inch Hooker telescope to photograph the Andromeda Galaxy and realized it was far beyond our Milky Way. That single discovery expanded the known universe from one galaxy to millions. But it also set up a plot twist. Andromeda and the Milky Way are on a slow-motion collision course right now, scheduled to merge in about 4 billion years. Don't panic, you'll be fine. Probably. You drift between the two merging galaxies and the gravitational tides are dizzying. Streams of blue stars arc above you, crimson gas clouds stretch like molten glass. You reach out, and the light slips through your fingers. The combined gravity pulls you toward the forming center, where a new, larger galaxy is taking shape. It's brighter, heavier, and slightly more chaotic, like a toddler made of supernovas. The quirky tidbit for this stretch of cosmic mayhem: Simulations show that some galaxy mergers can fling supermassive black holes completely out of their hosts at speeds of thousands of kilometers per second. They become rogue black holes, wandering between galaxies with tiny entourages of stars still bound to them, a cosmic version of a rock band that got kicked off its tour bus. Somewhere out there right now, one of these exiled titans is drifting through the void, invisible but humming with leftover gravity. Historians of astronomy still argue whether most large galaxies were built primarily through such mergers or through steady gas accretion along the filaments. Some think the early universe was dominated by violent collisions. Others picture a gentler, more continuous growth. The truth might be a blend, bursts of chaos punctuating long stretches of quiet accumulation. Either way, the result is the same. Galaxies grow up by bumping into each other. You float higher to get perspective. All around you, galaxies are meeting, parting, blending. Some collide head-on, some skim past each other in teasing flybys. Each encounter reshapes them. Spirals become ellipticals, irregular blobs smooth into elegant ovals. Every time you blink, 1 billion years slip by, and the chaos begins to look like choreography. The light show is intoxicating. When gas clouds crash together, they ignite massive starbursts that turn whole regions sapphire blue. Supernovae pop like camera flashes, sprinkling the darkness with heavy elements. Between bursts, faint dust lanes weave intricate patterns, hinting at the galaxy's former shapes. It's as if the universe can't decide between painting and sculpture, so it does both. You drift close enough to watch the merger's core. The centers of both galaxies are circling each other now, each harboring a growing black hole. They spiral inward, shedding energy in invisible waves of gravity, ripples that will, billions of years later, reach detectors on a tiny blue planet. The pair will eventually merge into one colossal singularity, a gravitational monarch ruling a newly unified galaxy. But that's still a long way off. For now, they orbit like wary dance partners, their rhythm both dangerous and oddly romantic. You imagine what it would look like from a safe distance. Two galaxies intertwining, arms entangled, halos shimmering, a slow waltz that takes hundreds of millions of years to complete. Astronomers on future worlds will call these shapes the antennae, or the whirlpool, naming them after the earthly patterns they evoke. Beauty, it seems, is a universal instinct. Above the collision, the cosmic web still gleams faintly, its filaments feeding the growing structures. Gas continues to stream in, replenishing what the mergers consume. The universe, though turbulent, never runs out of material to work with. Everything recycles, everything returns. You watch one more moment of creation, a fresh spiral arm forming out of chaos, a bridge of dust glowing faintly as newborn stars ignite along its length. It's delicate, temporary, perfect. Then you drift back, letting the scale of it sink in. Galaxies collide not in rage, but in inevitability. This is how the universe builds its masterpieces, slowly, repeatedly, without apology. Somewhere out there, the Milky Way is still small, still gathering its future partners. You'll meet it soon enough. For now, enjoy the view. Billions of galaxies swirling, merging, shining. It's the grand ballet of cosmic evolution, and you've got front row seats. You linger near the swirling aftermath of a galactic collision, watching the debris settle like glitter drifting in a snow globe. Amid the dust and chaos, something darker, quieter, and infinitely more powerful stirs at the center. It's not a star, not a cluster. It's the universe's ultimate paradox, a black hole. At first, you don't see it. How could you? Its presence is defined by absence. The only clue is the way nearby light bends, the way gas swirls faster as it spirals inward. You move closer, and suddenly the air, well, the space, feels heavier, as if time itself has grown viscous. This is a supermassive black hole, a gravitational pit millions, sometimes billions, of solar masses deep. It sits at the heart of nearly every galaxy, an invisible anchor holding the chaos together. You feel it pull at you, not enough to threaten, but enough to make your stomach, or your starlit equivalent, flutter. Gas from the merger streams toward it, heating up as it falls, forming a brilliant accretion disk that outshines the rest of the galaxy. Jets of plasma erupt from the poles, lancing through space for thousands of light years, its pure, quiet violence wrapped in mathematical grace. Here's your historical touchpoint. In the early 20th century, long before anyone could see such things, astronomers noticed mysterious radio sources and quasars, objects brighter than entire galaxies yet small enough to fit within a solar system. In 1963, Martin Schmidt cracked the riddle. These were the hearts of distant galaxies, powered by supermassive black holes feeding on matter. It was like discovering that the universe had volcanoes made of gravity. You float closer to one such quasar, and it's dazzling, light and energy spilling from the maelstrom like liquid lightning. Every particle in the disk screams around the hole at nearly the speed of light, compressed and superheated until it glows ultraviolet. The jet shoots out perpendicular to the disk, a stream so stable it could drill through eternity. You can feel the hum of magnetic fields twisting it tight. And here's your quirky tidbit. Some supermassive black holes actually sing. Not in any way you could hum along with, but through pressure waves in the surrounding gas. In 2003, scientists detected a note from a black hole in the Perseus cluster, a B-flat, 57 octaves below middle C. The universe literally hums its own bass line. If you could hear it, the sound would last for millions of years per beat. Historians and physicists still argue over how these monsters formed so early in the universe. Did they start small, growing from the collapse of the first massive stars? Or did entire clouds of primordial gas collapse directly into black holes, skipping the stellar phase altogether? The evidence is tantalizingly unclear. What's certain is that they appeared astonishingly quickly, some already billions of solar masses just a few 100 million years after the first stars. The universe wasted no time establishing its gravitational royalty. You watch as the black hole's influence ripples outward. It's not just a destroyer, it's a regulator, a cosmic thermostat. The energy from its jets and winds blows through the surrounding galaxy, stirring and heating the gas, sometimes preventing new stars from forming, sometimes triggering bursts of creation. It's a strange kind of balance, one that keeps galaxies from growing too fast or too still. The accretion disk glows like an eye, the jets carving twin beams through intergalactic space. You imagine the view from a distant planet, an alien sky split by a luminous spear of energy stretching across the heavens. For any civilization that ever looks up at it, this would be both a beacon and a warning. You drift back slightly, feeling the subtle gravity tug at your heels. The edge of the event horizon is shimmering, not literally, but in your mind. It's the boundary where escape becomes impossible, where space folds inward on itself. Cross that line, and time stops being a polite suggestion. Still, there's beauty here, a kind of hypnotic calm in the inevitability of it all. It's tempting to think of the black hole as the galaxy's brain, its controlling force. But that's not quite right. It's more like a heart, unseen, essential, pumping energy and rhythm through everything around it. Without it, the galaxy might fall apart. With it, it thrives in tension. And somewhere, not far away, others are forming. Nearly every growing galaxy has one. Some gentle, some ravenous. They're the quiet overseers of cosmic evolution, shaping not only how galaxies grow, but how they age. The merger around you settles further. The black hole feeds less greedily now, its jets thinning into ghostly streaks. The galaxy is stabilizing, finding its rhythm again. Stars orbit peacefully. The central glow softens. You can sense the balance returning. The chaos has done its job. Before you drift onward, you glance once more into that dark center. You imagine falling, slowly, into the event horizon, watching time stretch and twist as you approach, light bending around you in a final embrace. But instead of terror, you feel something almost tender. The black hole isn't hungry or cruel. It's part of the story, as necessary as gravity, as ordinary as silence. You pull back, letting the galaxy's light wash over you. The universe, it seems, loves contrast. Creation beside destruction, stillness beside collapse. And you, lucky wanderer, get to witness it all. Stars that die so galaxies can live, and voids so dense that they teach light how to curve. The next stop on your quiet journey, the invisible hands that make all this structure possible, the halos of dark matter that cradle every shining galaxy like cupped palms. But for now, you take one last lingering look at the black hole's faint glow and let it lull you. A heartbeat in the dark, steady and eternal. You leave the blinding quasar behind and let your eyes, or whatever cosmic sense passes for them, adjust to the softer light beyond. Around you, galaxies drift like glowing jellyfish in a midnight ocean, their shapes serene now, their tempers cooled. But beneath that calm exterior lies something far more mysterious and utterly invisible. The halos of dark matter. They don't shine, don't absorb, don't reflect. You can't see them at all. Yet everything, the galaxies, the clusters, the stars, even the quiet dust between, rests inside their unseen embrace. If you could strip the visible universe away, what would remain wouldn't be emptiness. It would be this vast skeleton of dark matter, humming silently, cradling creation in its invisible hands. You drift to the edge of one such halo. It's enormous, 10 times wider than the luminous galaxy it holds. There's no boundary, no shell, just a slow, diffuse gravitational presence. You feel its pull from every direction, like a whisper tugging at your atoms. You can't help but shiver. Here's your historical anchor for this dim revelation. In the 1930s, Swiss astronomer Fritz Zwicky studied the Coma cluster and found that the galaxies within it were moving too fast to be held together by visible matter alone. His conclusion? There had to be something else, something unseen providing the missing mass. He called it Dunkelmaterie, dark matter. Astronomers politely ignored him for decades because, well, Zwicky was kind of a handful, but as the evidence mounted, it became clear he'd been right all along. Now, from where you float, the idea is undeniable. Every galaxy you see sits inside one of these halos, spinning within its gravitational well. The stars are just the glitter on top, the foam on an ocean of invisible mass. Without these halos, galaxies would fly apart like dust in the wind. Here's the quirky tidbit. If dark matter particles are real, and most cosmologists are pretty confident they are, then right now, this very second, billions of them are streaming through your body, through the room you're sitting in, through the planet itself. They don't collide with atoms, don't slow down, don't care. You're constantly bathed in an invisible river of ghostly matter, and yet you feel nothing. It's like being hugged by the universe but never noticing. You sink deeper into the halo, moving away from the glittering center. The visible stars fade behind you, replaced by nothing. But the nothing has structure. If you could translate gravity into sight, you'd see filaments within filaments, small knots merging into larger ones, all moving in slow, steady currents. The dark matter isn't static. It's alive with motion, shaping everything we can see. Historians and physicists still argue passionately about what exactly dark matter is. Some believe it's made of weakly interacting massive particles, or WIMPs, lurking just beyond the standard model of physics. Others champion axions, ultralight particles that behave more like waves than points. A few even propose that maybe we don't need dark matter at all, that perhaps our understanding of gravity itself is flawed. The debate continues, heated yet oddly poetic, a contest over the meaning of invisible weight. You pass through regions where the gravitational density fluctuates, feeling gentle pressure differences like warm and cool air currents. In some areas, dark matter clumps tighter, creating denser knots that will soon host clusters of galaxies. In others, it's thin and silky, stretching across light years in ghostly sheets. It feels like wandering through fog that can think. It's strange how much you've come to rely on light, those bright stars and blazing quasars, to tell you where you are. Without them, the universe feels eerily intimate, as if you're inside its thoughts. The dark matter halo hums softly around you, its gravity translating into a vibration you almost mistake for music. The tempo is slow, the notes deep enough to rattle time itself. You imagine looking back at the luminous galaxy cocooned inside this vast halo. From out here, the galaxy seems so small, so fragile. Just a shimmering pearl nestled in an unseen hand. Every one of its stars, every orbit, every supernova owes its stability to the dark matter's grip. It's humbling to realize that what truly shapes the universe isn't what we see, but what we don't. And here's a comforting irony. The more invisible the force, the more essential it tends to be. Gravity, dark matter, the air around you, none visible, all indispensable. The cosmos seems to prefer its most important work to be done quietly, behind the scenes. You glide along the curvature of the halo, tracing where it blends into the filaments of the larger cosmic web. Tiny sub-halos like satellites drift nearby, each one holding its own miniature galaxy or dwarf companion. They move like a school of fish following a great leviathan, bound not by sight but by pull. You realize these smaller structures will one day merge into the main galaxy, enriching it, shaping its spiral arms and thickening its halo. You pause, letting your awareness expand. The dark matter stretches everywhere, billions of halos, each with its luminous heart, forming the framework of the entire universe. The web is complete now, a cosmic nervous system connecting every point of light. You can't help but marvel. Out of all the matter in the universe, only about 5% is the kind you know. Atoms, molecules, stars, you. The rest is dark matter and dark energy, unseen but utterly dominant. You are quite literally made of the minority substance in a cosmos that runs on shadows. And yet here you are, floating through the unseen, bearing witness to it. As you begin to drift back toward the light, the halo hums one last time, a soundless farewell, a reminder that everything visible owes its life to the invisible. Ahead lies a familiar glimmer, a gentle spiral you almost recognize. It's your home galaxy in its infancy, still raw, still gathering pieces of itself. Time to step closer and meet the Milky Way when it was still a wild child of the cosmic dawn. You drift through the web of unseen filaments until one particularly bright swirl catches your eye. It isn't majestic yet, more of a luminous bruise smeared across the dark, but something about it feels familiar. The curve of its gas, the tempo of its spin, the shy pulse of its starlight. You've found the Milky Way's earliest ancestor, your own galactic home when it was still young, raw, and delightfully chaotic. The baby Milky Way doesn't have arms yet, just loose streams of gas and a few embryonic clusters scattered through its halo. You float closer and sense its gravitational heartbeat, steady, confident, already gathering strength. This is about 13 billion years ago, give or take a cosmic shrug. The universe has matured past its wildest youth, and galaxies like this one are busy building character through collisions, accretion, and the occasional cosmic tantrum. You dive through its outskirts where cold hydrogen clouds pile up like drifting continents. Gravity stirs them, and star formation erupts in slow fireworks. Some of these newborn suns will live long enough to see the rise of planets. Others will burn themselves out before the Milky Way even develops a proper spiral. You can smell the faint ozone of radiation, sharp, metallic, almost nostalgic. Here's your historical marker. In 2018, the Gaia spacecraft mapped the precise motions of over 1 billion stars in the modern Milky Way, allowing astronomers to trace its history backward. What they found was stunning. Our galaxy is a patchwork, built from dozens of smaller galaxies that merged over billions of years. One of the largest mergers, dubbed Gaia Enceladus, or the Sausage Galaxy, no, really, crashed into the Milky Way about 10 billion years ago, puffing up its halo and seeding countless stars. Every time you look at the night sky, a good fraction of those stars are cosmic immigrants. You glide through one of these ancient collisions now. Streams of stars are crossing paths, arcs of gas glowing from friction, halos overlapping like translucent ghosts. The result isn't destruction, it's nourishment. Each merger fattens the Milky Way, spinning it faster, enriching it with metals forged in previous generations of stars, its cosmic layering at its most patient. The quirky tidbit: scientists think the Milky Way once had 2 major bars running through its centre, a double-barred galaxy, like a cosmic cocktail lounge. Over time, gravitational resonance simplified it into the single central bar we see today, but the remnants of the second linger in the orbits of older stars. The universe apparently has always been a fan of symmetry, with just enough imperfection to keep things interesting. Historians and astrophysicists still argue about when the Milky Way's iconic spiral arms actually appeared. Some simulations suggest they formed early, perhaps 9 billion years ago, as the galaxy settled into a rotational rhythm. Others believe they're more recent transient structures, density waves that sweep through the disk like patterns in a swimming pool. The debate is still open, and every new telescope adds another twist. You drift above the young galactic plane, watching the gas flatten into a disk. It's thick and turbulent, not yet the graceful swirl you know. Shock waves from supernova ripple across it, shaping vast cavities. These expanding bubbles collide, creating filaments where new stars bloom. The rhythm is hypnotic. Collapse, ignite, explode, repeat. Far below, dark rivers of gas are streaming inward from the cosmic web, feeding the galaxy's growth. They spiral in slowly, cooling as they go, forming rings that shimmer faintly. The Milky Way's halo glows with scattered clusters, globulars, each packed with ancient stars orbiting like loyal attendants. Some of those stars will outlive everything you know. You move toward the forming center, where a small, fierce black hole is gathering mass, an early ancestor of Sagittarius A star, the supermassive heart of the modern Milky Way. It's quieter than its quasar cousins, more reserved but no less important. Its subtle gravity helps regulate the flow of gas, keeping the core from overheating. Without it, the Milky Way might never have formed such perfect balance. As you watch, another small galaxy approaches, one of many to come. It's drawn in by invisible threads, moving gracefully as though accepting its fate. When it merges, new waves of star formation will bloom, and the Milky Way will take another step toward maturity. You realize you're witnessing the slow assembly of the home that will one day cradle the sun, earth, and you. It's strange to think that everything familiar, the moonlit nights, the ocean tides, the scent of rain on soil, traces its lineage back to these fiery clouds. Each atom in your body was once flung from a supernova somewhere in this galactic nursery. You are, quite literally, recycled stardust from the Milky Way's messy adolescence. The galaxy's rotation begins to smooth out now, its gas settling into elegant spirals. You can finally see hints of structure, arms forming where density waves compress gas into luminous lanes. It's still rough around the edges, but the pattern is unmistakable. The faint, luminous swirl that will one day dominate your night sky. You drift through one of these arms, brushing past blue clusters where newborn stars gleam like jewels. The light here is young, sharp, impatient. Dust glows faintly red, scattering starlight in every direction. It feels oddly intimate, like walking through the veins of something alive. From far above, the early Milky Way looks serene, almost complete. But you know better. It's still growing, still hungry. Over the next few billion years, it will feast on smaller galaxies, refine its spiral, and calm its violent heart. The cosmic teenager will become the grand, balanced adult galaxy you call home. You hover there a moment longer, tracing the curve of its nascent arms. The stars shimmer beneath you, a promise written in light. Somewhere, deep in that future, one of those arms will give birth to a small yellow star, and around that star a tiny world will form where creatures will one day look up and wonder where it all began. You smile. You've seen it now, the Milky Way's secret origin story, soft and sprawling, stitched together by collisions and time. And as you turn to drift onward, the galaxy's rotation hums beneath you like a heartbeat you almost recognize. Next, you'll watch the entire universe blossom, an era when billions of galaxies light up at once, turning the cosmic darkness into a slow sunrise that never ends. You rise above the plane of the young Milky Way and see the faint shimmer of a billion other lights flicker to life around it. What was once a sparse wilderness now blossoms into an overwhelming garden. The universe finally is in full bloom. Everywhere you look, galaxies sparkle like dewdrops caught in sunlight. Spirals, ellipticals, irregular blobs, all glowing in different shades and moods. Some are fiery blue, packed with hot newborn stars. Others are mellow amber, filled with ancient suns quietly fading. Together they form an infinite glittering coral reef floating in the black sea of space. You drift through this expanding cosmos, and it feels almost alive. Each galaxy a heartbeat, each cluster a breath. The scale defies reason. Light itself seems slower here, weighted by sheer abundance. You could spend eternity wandering and never see the same configuration twice. This is the cosmic high noon, roughly 10 billion years ago when galaxies are at their most active. The gas from the early universe has finally cooled enough to settle into star-forming disks. Everywhere, matter is transforming into light. You can practically smell the ionized air, the ozone tang of radiation and youth. Your historical anchor hums in. In the late 1990s, the Hubble Deep Field images revealed thousands of galaxies in what appeared to be a blank patch of sky, no bigger than a grain of sand held at arm's length. Every speck in that image, each smudge, swirl and spark, was a galaxy. many from this very era of cosmic bloom. Humanity realized then that the universe isn't just vast, it's saturated. Wherever you look deeply enough, creation stares back. You glide toward a cluster of particularly vivid spirals. They twirl lazily in formation, each one emitting soft radio whispers, X-ray sighs, and ultraviolet shouts. The light is everywhere, constant, glittering, relentless. The cosmic dark ages are long gone. The universe is wide awake, and it's not going back to sleep anytime soon. Here's your quirky tidbit. The universe at this point is making about 10 times more stars per year than it does today. Astronomers call it the cosmic noon because after this, galactic star formation will slowly decline, like the afternoon cooling into twilight. You're floating through the brightest moment in universal history, 1 trillion suns flickering all at once. But there's still structure amid the chaos. You notice how galaxies trace out the same great filaments of dark matter you saw earlier. The cosmic web hasn't disappeared, it's just glowing now. Its nodes have grown fat with light. The universe has gone from scaffolding to architecture. Historians of science still argue about what triggered this golden age of star formation. Was it simply the cooling of the primordial gas? Or did feedback from early black holes stir things up, spreading metals and turbulence that jump-started new stars? The data leans one way, then the other, depending on the telescope and the decade. It's one of astronomy's favourite debates, how the lights really came on. You float past a massive elliptical galaxy, its edges hazy, its colour leaning gold. This one's old already, even now, its star-forming days mostly behind it. It's a relic of the early mergers, bloated and luminous but serene. Its central black hole flickers gently, resting after a feast. In contrast, nearby, a small spiral spins rapidly, still busy with creation. You realise galaxies, like living things, have life cycles. Some burn bright and fast, others coast gracefully into old age. You take a wide view and try to absorb it all. Hundreds of billions of galaxies, each with billions of stars, each star with planets, moons, dust rings, comets. The sheer probability of existence feels dizzying. Somewhere in all that, countless worlds are taking shape, some barren, some watery, some maybe already wondering what else is out there. You're floating through the universal moment when possibility is at its maximum. You brush past a spiral arm bursting with new stars. The radiation tickles, sharp but invigorating. Young suns flare wildly, their solar winds carving cavities in the gas. The dust glows orange-red, like embers in slow motion. Every now and then, a supernova punctuates the scene, a sudden bloom of brightness that lasts a few weeks, then fades, leaving behind a neutron star or a black hole. You've seen so many now that you've come to expect them, like the universe exhaling punctuation marks in its endless story. And here's a small joke the cosmos seems to be playing on itself. Even with all this light, space still looks mostly empty. The distances are so immense that brightness becomes solitude. Each galaxy shines alone, separated by millions of light years of darkness. It's a strange kind of loneliness, an illuminated silence. You glide past a galactic cluster, and the temperature spikes. Between the galaxies, a thin mist of plasma glows faintly in X-rays. It's the intracluster medium, the leftover breath of all the stars that ever lived here. You can feel it shimmer against you, ancient and wise. Farther out, the filaments fade, the light softens. You notice the subtle shift. Star formation is beginning to slow in some regions. The gas reserves are being used up, transformed into stars faster than they can be replenished. The universe, for all its brilliance, is already hinting at decline. You wonder if it knows, or if it simply burns because burning is what it was born to do. You pause at the edge of a glowing field of spirals, each one turning slowly in perfect indifference. Time stretches, centuries passing between heartbeats. The light of 10 billion stars washes over you, gentle and infinite. You think about the Milky Way, now a small part of this vast chorus, its arms glowing among the rest. It doesn't stand out, it doesn't need to. It's just one note in a symphony that began long before you arrived. You drift further into the golden haze and the soundless radiance fills you completely. The universe is at its brightest, its most alive. From here, it feels like standing in the middle of eternity's heartbeat. But you know it won't last. Even the cosmos, for all its grandeur, must eventually exhale. Next, you'll move into that in-between era, the mysterious dawn when all this light began clearing the last of the cosmic fog, a moment scientists still argue about over coffee and equations. But for now, you let yourself rest here, suspended in brightness, where the universe hums at full volume. You ease away from the golden blaze of cosmic noon, and at first the darkness feels unfamiliar again, like stepping from a festival into an empty street. The light hasn't faded, it's simply thinned, stretched by distance, softened by time. Ahead lies an epoch where the universe learns transparency, the era of reionization, the cosmic clearing of fog. You slow down, feeling the texture of the intergalactic medium brush against you. It's not quite air, not quite void, a thin soup of hydrogen atoms still clinging to their electrons, neutral and opaque. Every photon from every newborn star must battle its way through this haze. Slowly, steadily, the light wins. The process is beautiful and brutal all at once. Ultraviolet radiation from the first stars and quasars slams into the surrounding hydrogen, ripping electrons free. The fog lifts. Space becomes see-through for the first time since the universe was a few 100,000 years old. You can almost taste the change in the air. Sharp, metallic, newly ionized. Your historical anchor hums faintly beside you. In 2001, the Wilkinson Microwave Anisotropy Probe, WMAP, detected subtle polarization patterns in the cosmic microwave background that hinted at this very transformation. Later, in 2018, the Planck satellite refined those measurements, suggesting rionization began around 400 million years after the Big Bang and ended about 1 billion years later. Not bad detective work for creatures who can't even see hydrogen with their naked eyes. But here's the quirky twist. The details are still maddeningly vague. Astronomers call this period the Foggy Dawn, because no telescope, yet, has captured it in full clarity. We can see before and after, but the middle remains a blurred dream. Some suspect small dwarf galaxies did most of the ionizing work. Others point to quasars, those blazing black hole hearts, as the main culprits. And a few theorists insist there must have been an unseen population of faint, fast-burning stars doing the heavy lifting. Historians of science will one day look back on this argument and chuckle, or sigh, depending on how long the mystery lasts. You hover above a young cluster where the transformation is visible in motion. The core glows brilliant blue, the outskirts shimmer pink, halfway between shadow and light. You can see ionization fronts spreading like dawn across the intergalactic clouds, huge spherical waves of transparency expanding from each starburst. It's hypnotic, a cosmic sunrise in every direction. The light has texture now. You watch photons scatter and then slip free, traveling unobstructed for the first time. The universe, once wrapped in fog, becomes glass. From here onward, light can truly roam, carrying information across billions of years. It's the moment when observation itself becomes possible, when the cosmos finally lets itself be seen. You pass a patch of still neutral hydrogen, one of the last holdouts. It's dark and dense like an island in the dawn. Radiation from nearby galaxies begins to nibble at its edges, and wisps of blue light curl inward, devouring the shadow. You stay just long enough to witness the final spark, a brief, silent flash as the last electron escapes. The island vanishes, leaving nothing but starlight. For a second, everything seems to sigh. The universe relaxes into clarity. It's brighter, thinner, and somehow older, as though the act of becoming transparent cost it a little innocence. Here's your sleepy smile moment. If you could have seen this from afar, the entire cosmos would have glowed like a frosted sphere, flickering as rionization patches overlapped. Imagine a snow globe of light turning itself inside out, each sparkle a pocket of new transparency. It would have been breathtaking, and slightly seizure-inducing, but mostly breathtaking. You drift back through the ionized gas, tracing faint filaments that now gleam faintly in ultraviolet. The galaxies within them shine unhindered, their photons finally free to cross the universe. Those same photons, stretched by time, will someday reach telescopes on Earth as ancient red light. You think of the astronomers who will catch them, hands trembling as they realize they're holding a message from this very dawn. The debates still continue, over when, over how, over who did it. But you can feel that none of that matters out here. What matters is that the fog has lifted. The universe can see itself now. Stars see each other. Galaxies exchange glances across impossible distances. It's a slow awakening, not of consciousness, but of connection. You hover a little longer, watching the light ripple outward. Every photon seems eager, as if aware of its mission, to travel, to illuminate, to tell the story. And you realize that without this clearing, there would be no cosmic history to observe, no starlight to map, no galaxies to study, no sleepy narrator whispering you toward dreams. Beyond this era lies calm and structure, the universe's quiet middle age, where magnetism, chemistry and time begin shaping subtler patterns. But before you drift onward, you take one last look at the luminous mist fading into transparency. It's the moment the cosmos became visible to itself. The fog is gone. The silence feels lighter. You exhale with it. You drift through the freshly cleared cosmos, where light moves freely now, unbothered and triumphant. The fog is gone, but the air of mystery remains. Because even though the universe has opened its eyes, there are still forces at play that don't quite show their hand. You sense them before you see them, faint vibrations threading through the galaxies, magnetic fields, the quiet architects. They don't blaze like stars or swirl like galaxies. They're subtle, invisible, more suggestion than substance, but they're everywhere. Every galaxy you pass hums with them, faint yet unmistakable. Lines of magnetism run through the cosmic gas, shaping it, guiding it, sometimes even sculpting it into elegant spirals. You follow one of these invisible trails, feeling it bend gracefully beneath your touch, like tracing the grooves of a sleeping giant's palm. These magnetic fields didn't arrive late to the party. They've been here since nearly the beginning, seeded in the primordial plasma after the Big Bang. Tiny fluctuations amplified over billions of years. Some were born from turbulence in the first stars, others sparked from the movement of charged particles as galaxies spun themselves awake. You watch as faint threads weave through interstellar clouds, coaxing the gas to align, twist, and condense. Without these unseen fields, the galaxy's shape would be different, its stars scattered less gracefully, its spirals far less defined. Here's your historical anchor. In 1949, physicist Hannes Alfvén proposed the theory of magnetohydrodynamics, describing how magnetic fields and plasma interact in space. He was ridiculed for thinking cosmic magnetism mattered. 2 decades later, observations proved him right, earning him a Nobel Prize. His equations became the quiet language of galactic weather. The science of how magnetic whispers control cosmic storms. You pass near a glowing nebula within a spiral arm. Dust grains within it have aligned themselves with the local magnetic field, like compass needles in slow motion. Polarized light leaks from the cloud, a soft blue shimmer that reveals the otherwise invisible lines of force. You can almost hear them, a low hum that vibrates against your thoughts. It's not sound, but something older, the physics of direction itself. Here's your quirky tidbit. The Milky Way's magnetic field is about 1 microgauss strong. That's 1,000,000 times weaker than a refrigerator magnet, and yet it shapes entire rivers of gas hundreds of light years long. Weakness, it seems, is not the same as insignificance. The cosmos loves irony almost as much as gravity does. Historians of science and astrophysicists still argue over how these magnetic fields became so organized. Did galaxies inherit them from the universe's infancy, or did they build them internally through motion and feedback? Some models suggest dynamo effects inside galaxies amplify small seed fields through rotation, like a cosmic battery endlessly recharging itself. Others insist the fields came preloaded, woven into the fabric of space-time. Either way, they're indispensable. Without them, cosmic rays would move freely, star-forming clouds wouldn't compress properly, and interstellar chemistry would lose its rhythm. You drift along one of these magnetic veins, and it feels like gliding down an invisible river. The gas flows with you, gentle eddies of hydrogen turning lazily. Farther along, you find a supernova remnant, an expanding bubble of hot plasma still buzzing with residual energy. Its magnetic field lines twist and loop, carrying fragments of the explosion's memory across light years. The patterns are intricate, almost artistic, frozen fireworks drawn in invisible ink. Everywhere you go, magnetism is doing quiet work, bending jets from black holes, shaping planetary systems, helping stars shed their winds. You realize that even in the smallest scales, From the core of a newborn star to the empty gulfs between galaxies, these fields are constant companions. They give the cosmos texture, a sense of continuity. You pass through a region of intergalactic space where the magnetism is faint but vast, spanning millions of light years. No one's quite sure how these enormous fields formed, but they exist, threading through the cosmic web like embroidery on an invisible fabric. You can feel the tension in them, stretched between clusters, guiding charged particles across the void. It's strangely comforting, like realizing that even the emptiest spaces are never truly empty. You pause near a faint galaxy cluster and watch as streams of plasma from active black holes interact with these fields. The jets twist into elegant corkscrews, glowing faintly in radio waves. You recognize this as the handiwork of magnetism, a gentle sculptor turning chaos into choreography. It's as if the universe is learning calligraphy, drawing its thoughts in arcs of charged light. If you could capture this entire view in human color, it would look almost like aurorae draped across eternity. Greens, purples, and golds shifting slowly in silent patterns. You imagine a cosmic aurora borealis that never fades, one that hums to itself across time. You think, perhaps a bit sleepily, that magnetic fields are the universe's softest voice. They don't shout like supernovae or blaze like quasars. They whisper, influence, and persist. They thread through every story the cosmos tells, quietly ensuring it all holds together. For a moment, you feel oddly protective of them. These unsung forces, too subtle for headlines, too patient for spectacle, are the universe's proof that elegance doesn't need applause. You glide onward, the faint magnetic lines brushing past like strands of spider silk. The galaxies ahead look calmer now, their shapes defined, their stars stable. The great fires of formation have cooled into rhythm. Everything hums in balance, poised between energy and rest. But balance, as always, is temporary. Ahead lies the chemical awakening, the era when stars begin cooking the heavier elements that will one day build worlds, oceans, and dreamers. The quiet sculptors have finished their groundwork. Now the alchemists take the stage. You leave the soft hum of magnetic lines behind and drift into the glowing bellies of the galaxies themselves. The light here is warmer, richer, no longer just hydrogen blue and helium white, but tinged with golds and reds and faint metallic sparkle. Something new has begun to happen inside the stars. The universe, once content with simplicity, has started practicing alchemy. You hover near a middle-aged star, one of millions beating gently in a spiral arm. Its surface roils in slow motion, bright granules rising and falling like golden foam. Deep inside, nuclei are smashing together. Hydrogen into helium, helium into carbon, carbon into oxygen. Every fusion is a step up the periodic staircase. The star doesn't know it's creating chemistry. It just burns because that's what gravity demands. But you, watching from a safe distance, realize you're witnessing the manufacture of everything that will someday become bones, oceans, and coffee spoons. Your historical touchstone drifts by. In the 1950s, a group of 4 scientists, Burbage, Fowler, and Hoyle, wrote a paper explaining exactly how stars forge elements heavier than hydrogen and helium. Their work, now called the B2FH paper, became the recipe book of cosmic alchemy. It proved that the atoms in your body were literally cooked in stellar furnaces. Every breath you take is recycled starlight. Fred Hoyle, by the way, was the one who sarcastically coined the term Big Bang while arguing against it. The universe apparently has a sense of humour about branding. You drift deeper into a star-forming region, a nursery where newborn suns cry out in ultraviolet bursts. Gas clouds ripple with colour, each hue marking a different element. Neon flashes orange, oxygen glows green, hydrogen pulses crimson. It's less a cloud and more a cathedral of chemistry. You float through it, slow and reverent, letting photons brush past your face like incense smoke. Here's your quirky tidbit. Gold, platinum, and many of the heavier elements aren't made inside ordinary stars at all. They're born when neutron stars collide. 2 ultra-dense stellar corpses smashing together in a brief, spectacular kiss. For a few seconds, they release more heavy elements than a galaxy produces in a million years. Somewhere, a ring on someone's finger or a circuit in someone's phone contains atoms that began in one of those cosmic collisions. The ultimate luxury brand, forged in stellar catastrophe. Historians and astrophysicists still argue about how evenly this chemical wealth spread through the early universe. Did the first supernovae enrich space quickly, or did it take hundreds of millions of years of mixing? Observations show surprising patchiness. Some galaxies are metal-rich while others remain almost pristine. It's as though the universe decorated itself unevenly, experimenting with style before settling on a look. You move toward a dying giant, a red supergiant swollen nearly to bursting. Its surface quivers like slow-motion lava, each pulse sending waves of heavier elements outward. Inside, fusion is running out of fuel. Soon gravity will win, and the core will collapse, triggering a supernova so bright it will outshine an entire galaxy for weeks. You hover nearby as the inevitable happens. The collapse is sudden, violent, and, oddly, beautiful. Layers of gas rush inward, bounce, then blast outward in a shimmering shockwave. You watch atoms scatter across light years: iron, nickel, silicon, calcium, carbon, all flung into the interstellar sea. It's destruction, yes, but also distribution. The star has turned itself into a gift basket of matter. For a moment the shockwave hits you, a ripple of energy passing through your incorporeal self, and you hear it as a deep, resonant chord. Not noise exactly, but meaning. The sound of the universe refreshing its palate. The expanding shell cools, and new molecules begin to form within it. Already, dust grains, tiny, complex crystals start to coalesce. Some will become part of future stars. Others will drift for eons until a planet's gravity claims them. You turn slowly, watching other stars live, die, and enrich their surroundings. Each death seeds the next generation. The galaxy has become a chemical factory, running on patience. The air between stars, once pure hydrogen, is now a cocktail of possibilities. Carbon monoxide, ammonia, water vapor, even traces of organic compounds. It smells faintly sweet, like burnt sugar and static. The patterns are mesmerizing. In some regions, the gas glows with the distinctive pink of hydrogen alpha radiation. In others, you see dark lanes where carbon dust has thickened into filaments. The interplay of light and shadow feels almost alive. You think of it as the cosmos version of gardening, stars growing elements the way trees grow fruit, then scattering them for whoever comes next. A small joke crosses your mind. If the universe had a kitchen, it would never wash its dishes. It just keeps reusing the same cosmic bowl, mixing new recipes from the leftovers of old ones. You drift past a young solar nebula forming in the wake of a nearby supernova. The cloud is rich with metals. Astronomers speak for anything heavier than helium. Tiny grains stick together, forming pebbles, then boulders, then protoplanets. You can already see faint rings forming around the central star. This is the next logical step in the chemical story, turning dust into worlds. But not yet. The universe isn't ready for quiet oceans and stubborn microbes. For now, it's enough that the ingredients exist, that carbon and oxygen have found each other, that iron and silicon know how to bond, that complexity is now a law, not a miracle. You look back toward the dying supergiant's fading shell, still glowing faintly in infrared. Its atoms will wander for billions of years before ending up in something that breathes. You feel an odd, gentle gratitude on their behalf. The galaxies around you hum softly, their colours deeper, their chemistry richer. The cosmos has learned how to cook. Ahead, the light flickers and shifts. Explosions have calmed, but winds remain. Vast rivers of gas blowing from star clusters, shaping the very architecture of galaxies. The chemical artists have done their work. The weather gods are about to take over. You move away from the star-forging furnaces and into open galactic air, where the glow turns diffuse and silvery. The noise is gone. No roaring fusion, no blinding detonations. Just a low, continuous hum. But there's movement all the same, a ceaseless push and pull through the lanes of gas and dust. The universe has weather now, grand, invisible storms that sweep across galaxies like slow hurricanes. You cross the threshold of a spiral arm and feel the change immediately. The stars ahead are bright and hot, their radiation spilling outward like a breeze made of light. Behind them trails a mist of charged particles, stellar winds, gentle at first, then relentless. They blow cavities into the surrounding gas, clearing pockets of vacuum where new stars will someday ignite. Each gust reshapes the interstellar landscape. These winds are more than decoration. They are engines of evolution. When thousands of stars blow together, their combined outflow becomes a galactic wind, capable of expelling entire rivers of gas into intergalactic space. You watch one such current drift upward from a galactic disk, a translucent plume glowing in soft X-ray light, expanding like a jellyfish made of plasma. It's graceful, dangerous, necessary. Here's your historical anchor. In the 1960s, astronomers began noticing that some galaxies were losing mass faster than expected. The culprit, discovered later, was feedback, energy from supernovae and stellar winds blowing material out of galaxies. Today, spacecraft like Chandra and XMM Newton photograph those winds in exquisite detail, showing fountains of gas that rise tens of thousands of light years before falling back in cosmic rain. You follow one such fountain. The gas arcs high above the galaxy's plane cools, condenses, and descends again, a glittering drizzle of enriched material. It's a recycling system on a scale that would make any environmental scientist blush. Stars die, blow metals into space, and the galaxy gathers them up again to build new stars. The circle of life, just with a bit more plasma and fewer singing animals. The quirky tidbit here: some dwarf galaxies are so small that a single burst of star formation can blow them completely empty. One cosmic sneeze, and poof, no more gas to make stars. They become ghost galaxies, filled only with dim, aging suns and the faint echo of what might have been. Yet those same expelled gases often drift away to seed new systems elsewhere. The universe never truly wastes anything. It just redistributes. Historians and astrophysicists still argue about how strong these winds really are. Do they dominate galactic evolution, regulating star formation like cosmic thermostats? Or are they side effects, local storms that look dramatic but change little in the grand scheme? Simulations swing between extremes. Some suggest galaxies would choke on their own gas without these outflows. Others hint they'd simply evolve slower. The debate is, fittingly, as turbulent as the subject. You hover inside one of these cavities, where the pressure difference creates a shimmering wall of compressed gas. The colours here are stunning: emerald where oxygen dominates, ruby where hydrogen glows, violet where helium burns brightest. It's the visual equivalent of thunderheads at sunset. You drift closer until the surface ripples from your presence, and you imagine the galaxy shivering around you. A burst of X-rays passes through, the mark of a recent supernova. You can feel the shockwave echo through the gas, stirring eddies and currents. It's strangely soothing, like the deep rumble of distant thunder on an endless night. Farther ahead, in the galactic halo, the expelled gas meets intergalactic wind. Streams of matter drifting between galaxies. The two collide in slow-motion fronts, forming delicate shock patterns that stretch for light years. You realize the boundary of a galaxy isn't sharp, it's porous, breathing in and out like lungs. You remember, almost fondly, that even the Milky Way is exhaling this way right now. Great fountains of hot gas streaming above and below its disk, known as the Fermi bubbles. They extend nearly 50,000 light-years in both directions, glowing faintly in gamma rays. Discovered in 2010, they're still a mystery. Some say they're the remnants of an ancient feeding frenzy from our central black hole. Others think they're the collective sigh of long-dead stars. Either way, they're proof that even galaxies need to vent sometimes. You continue drifting upward, watching the glow fade from blue to faint amber as the gas cools. Tiny crystals, silicates, graphite, form within the outflow, the raw material of dust. When the wind finally slows, those grains will fall back into the disk and become the seeds of new planets. It's cosmic composting, the endless cycle that ensures every bit of matter gets at least a few starring roles before the credits roll. The thought makes you smile. Somewhere far in the future, an atom from this very outflow might end up in a planet's mountain, a creature's bloodstream, or maybe in someone's cup of tea. Cosmic weather has a long reach. From this high vantage point, you can see the galaxy's structure in motion. Spiral arms pulse with birth and death, winds rising and falling in slow rhythm. It's easy to imagine the entire system breathing, inhale, exhale, repeat, over billions of years. The magnetic fields you left behind ripple gently, shaping the flow. Gravity keeps the pattern steady, while energy keeps it restless. The universe feels less like machinery now, and more like metabolism. Everything moves, transforms, exhales, begins again. The soundless rhythm of expansion and collapse has become almost lullaby-like. You could drift here forever, letting the warm winds carry you in their slow spiral. But beyond this, farther out, lie older lights, the faint, distant glow of galaxies that no longer burn with youth. Their brilliance has softened into whispers, their shapes blurred by time. The winds will fade, the storms will quiet, and the universe will turn its attention to memory. Before you follow it there, you take one last look at the glowing plume beneath you, shimmering like candle smoke in zero gravity. Somewhere inside, atoms you just watched scatter are beginning their long journey toward new beginnings. Even in silence, the galaxy keeps moving. You follow the galactic winds outward until they thin into the quiet between clusters, where the light softens to a faint mist and time stretches almost beyond your grasp. Out here, everything feels slower, deeper. You're gliding through the echoes of the first galaxies, light so ancient it's nearly soundless, photons stretched thin by the universe's expansion, arriving billions of years late but somehow still on time. The glow around you isn't from nearby stars, but from the ghosts of long-vanished galaxies. Their light has travelled across the whole observable universe just to reach you, faded, reddened, but persistent. Each beam is a postcard from the distant past, written in a language of wavelength and patience. You let it wash over you, warm and cold at once, memory incarnate. You turn slowly and the view becomes dizzying. Every direction is a different century. The deeper you look, the younger the universe becomes. It's like falling backward through history, past eras of birth and bloom, all the way to the first sparks of light you saw so many sections ago. You realize the universe isn't just big, it's recursive, always reflecting on itself through time. Your historical anchor drifts in like a flicker of gold on black. The 2022 launch of the James Webb Space Telescope. With its infrared eyes, Webb began uncovering galaxies so far away that their light started its journey over 13 billion years ago. Some of these galaxies appeared shockingly mature, massive, organized, even possessing spiral shapes far earlier than theories expected. The discovery sent cosmologists into delightful chaos, rewriting the timeline of galactic evolution almost overnight. Here's your quirky tidbit. One of Webb's first deep-field images showed a galaxy nicknamed the Sparkler, so far away its light began when the universe was less than 1 billion years old. Surrounding it were tiny dots, globular clusters glittering like jewellery. Astronomers had to stop and laugh at the name's coincidence. It really did look like a sparkler being waved on the 4th of July, except it was 13 billion years old and moving away at 1/3 the speed of light. Historians of science will probably keep debating how these early galaxies formed so quickly. Did the first stars clump together faster than expected? Did dark matter halos create instant scaffolds for galaxies to grow upon? Or, dare we whisper it, does our understanding of cosmic time itself need tweaking? The conversation continues, proof that even with the universe spread out like an open book, we're still learning how to read. You drift among the ancient light, feeling each photon as a faint brushstroke on your skin. It's hard not to get sentimental. This light was born before Earth existed, before the Milky Way settled into its graceful form. It has crossed unthinkable distances, dodged dust clouds, redshifted through expanding space, and yet here it is, arriving intact. You can almost imagine it sighing in relief, finally. From your vantage point, the faint smudges of those early galaxies look like ghosts underwater. They shimmer, distort, and vanish as you move. You realize you're watching them through time's aquarium glass. The farther back you peer, the more the universe resembles memory itself. Fragmentary, flickering, stubbornly incomplete. In one corner of the cosmic panorama, a cluster of early galaxies forms a chain, their halos overlapping like linked pearls. They share gas, gravity, and the faintest whisper of magnetic connection. You can see them merging even now, their shapes bending toward one another in slow, inevitable affection. The collision will take hundreds of millions of years, but light allows you to see it as one fluid gesture. You pass through the space between them, feeling the heat of their combined radiation. It's soft but insistent, like the warmth of sunlight on skin long after sunset. Around you, the intergalactic medium glows faintly with scattered photons. the cosmic background light that fills every corner of space. It's not bright enough to see with human eyes, but it's there, the afterglow of everything that ever shone. You can't help thinking about the irony. The farther you go into the past, the more complete the picture becomes. Every ancient galaxy, every fossil light source is a fragment of a story that only reveals itself in hindsight. Astronomers on Earth call this look back time, but from here it feels more like look within time. You're seeing the universe remembering itself. If you listen closely, no, closer still, you might imagine a faint hum, the collective vibration of all that ancient light blending into one continuous chord. It's the sound of persistence, of time refusing to vanish entirely. You can almost drift asleep to it, a lullaby sung in wavelengths billions of years long. You tilt your gaze toward one particularly faint patch of sky. Nothing seems there, and yet, statistically, there must be thousands of galaxies within that void, too faint or too redshifted for even the best instruments to detect. The unseen outnumbers the seen, always has, always will. That's the universe's favourite trick, abundance masquerading as emptiness. The light around you flickers subtly as space continues its expansion. Each photon stretches thinner, cooler, quieter. You can feel entropy at work, a gentle slowing, the universe taking deeper, longer breaths. It's not dying, not yet, but it's certainly maturing. The first rush of youth has passed. The cosmos now carries memory like a perfume, subtle and irreversible. You realize that everything you've witnessed tonight, from the earlier sparks to these fading echoes, exists simultaneously, layered across time. The light that began billions of years ago still travels, still glows, still is. The universe doesn't discard its past. It preserves it in motion. You drift one last time through the ancient glow, letting the soft radiation seep into your thoughts. It feels like walking through a gallery of cosmic ancestors. Every shimmer a portrait, every red hue a whispered name. You could stay here forever, surrounded by light older than language. But the story isn't done yet. Ahead you can already sense movement, a return, a cycle. The universe has learned to reuse its own dust and gas, to build anew from what came before. The next chapter isn't about birth or destruction, but about something subtler, wiser, recycling. You take one last slow look back. The first galaxies wink faintly behind you, their light finally completing its impossible journey. You nod to them in silent gratitude. Their echoes have told you everything you needed to know about beginnings. Now it's time to learn what happens after. You turn from the dim glow of ancient galaxies and ease forward into gentler light. The explosions are fewer now, the violent births less frequent. Everything feels steadier, older, wiser, almost meditative. You're entering the cosmic recycling program, the slow, eternal choreography where dust, gas and starlight trade places like dancers changing partners. It begins small. You watch a supernova remnant from earlier sections expand and cool, its colourful shock front fading to transparent grey. The debris drifts, mingles with interstellar gas, and becomes invisible, except to patient eyes. Over millions of years, gravity will nudge this enriched material back into clouds. Those clouds will collapse into new stars, and the process will repeat. Nothing is lost, it just changes costume. The galaxy you hover above hums quietly with this rhythm. The bright spirals are mottled with dark lanes. Those are the star factories, thick with dust and molecules. Between them float older stars shedding their outer layers, each one a slow exhalation of carbon, oxygen and nitrogen. You could almost call it cosmic respiration. Inhale gas to make stars, exhale dust when they die. A historical whisper crosses the darkness. In the 1980s, astronomers using the IRAS satellite discovered that galaxies radiate far more infrared light than expected. The culprit wasn't stars but dust, tiny smoky particles re-emitting starlight as gentle heat. For the first time, scientists realized just how much of the universe's luminosity comes from recycling, not creation. Half of all light, hidden in warmth. You drift through one of those dusty lanes and the view is startlingly intimate. The grains are microscopic, but there are billions of them. Silicates, graphite, frozen water, simple organics. They clump together, forming larger motes that tumble slowly in the dark. The scent here, if a light had scent, is metallic and sweet, like a memory of ozone and old rain. A nearby red giant begins to pulse. With each breath-like rhythm, it sheds more of itself, forming a faint shell that expands outward. You realize that much of the interstellar dust around you was once part of such stars, literal exhalations of suns. The material drifts and gathers, guided by turbulence and magnetic eddies, until it joins a cloud dense enough to collapse again. Star dust, a cycle so elegant it feels almost holy. Here's your quirky tidbit. Some of that dust, after billions of years of cycling through stars, planets, and comets, eventually finds its way into you. Every carbon atom in your DNA, every calcium atom in your bones has made this journey. You are, in the most literal possible sense, recycled stardust with opinions. Historians and astrophysicists still debate how efficient this cosmic recycling really is. Some models say galaxies reuse nearly all their matter over time. Others insist much escapes into intergalactic space forever. The truth, as always, lies somewhere in the shimmering middle. Enough retention to sustain creation, enough loss to keep the universe restless. You float past a molecular cloud the size of 1,000 solar systems. Inside, tendrils of dust twist like smoke, gathering around dense cores that shine faintly in infrared. Stars are forming here, invisible in visible light but radiant in warmth. You imagine each as an ember glowing behind gauze. Around them, disks of dust are flattening, clumping, spinning, seeds of future worlds. You linger near one such disk, watching it swirl. Pebbles knock together, stick, grow. Tiny gravity wells form. You're watching the early sketches of planets, drawn from the remnants of older stars. It's strange how slow it looks, like someone building a cathedral one grain of sand at a time. Yet given enough patience, this cloud will become a solar system, complete with asteroids, moons, and maybe, if fortune permits, oceans. You pull back to see the galaxy as a whole, and suddenly the pattern is obvious. The same golden dust that veils newborn stars also decorates the halos of dying ones. The circle is perfect. Light creates matter, matter recycles into light. Nothing stands still, but nothing truly ends. In the spaces between galaxies, the cycle continues. Streams of gas stripped by galactic winds drift into the void, where they may someday fall into another system entirely. You imagine a molecule of oxygen starting here, blown from a star, cooling in intergalactic exile, then drawn into a new galaxy billions of years later to become part of another sun. That molecule will never know its story, but you do. It's comforting in a strange way, the idea that the universe remembers itself through transformation. The soft glow from the dust is almost hypnotic now. Infrared waves shimmer like embers under ash. You could float here for ages, half asleep, feeling the gentle pulse of renewal all around you. Even decay, it turns out, has a rhythm. You pass through a region where recycled material is especially rich. The colours deepen, orange, crimson, bronze. You sense organic molecules here, complex carbon chains forming spontaneously in the cold. They drift through space like invisible seeds. Somewhere, one will land on a newborn planet and become the basis for something alive. You grin at the thought. The cosmos apparently composts with purpose. From your vantage point, the galaxy looks almost alive, a self-sustaining ecosystem, every death feeding a birth, every storm clearing the air for calm. It's a pattern that repeats across billions of light years. The quiet truth that the universe's favourite trick isn't destruction, but renewal. The air, or rather the absence of it, feels warm with meaning. You realise that even the fading light of ancient galaxies is being recycled too. The cosmic microwave background, once the glare of creation, has cooled into a gentle warmth that still fills every inch of space. The universe even reuses its photons. You close your eyes for a moment, feeling the deep pulse of continuity. The same processes that build galaxies and stars will one day fade and return, reshaped. Nothing is wasted, not even time. Ahead, you can sense the next transition, the slow drift into age when the universe's energy starts to wane and galaxies begin to quiet. The recycling continues, but the tempo slows, like a song winding down. For now, though, you linger in the middle of it, suspended in the galaxy's gentle exhalation, surrounded by the scentless perfume of dust and light. You're floating in proof that nothing is ever truly gone, just rearranged, endlessly, beautifully, again and again. The galaxies grow quieter as you drift onward. The glow that once burst from every corner of the cosmos now feels subdued, softer, like a candle burning low after a long night of celebration. You've reached the twilight of star formation, an era when galaxies grow old. It doesn't happen all at once. From a distance, they still look magnificent, spirals with bright cores, ellipticals with hazy halos, but the energy inside them has changed. The once turbulent gas clouds have thinned, their supplies depleted by billions of years of stellar births. Fewer stars are forming now, and the ones that do are smaller, cooler, dimmer. The universe is exhaling, gently, gracefully. You float near a spiral galaxy that has seen better days. Its arms are pale, its dust lanes faint. The brilliant blue clusters of young stars that once traced its arms are mostly gone, replaced by soft amber light from older, quieter suns. If the galaxy had a voice, it would sound like a retired musician humming to itself, no longer performing, but still resonating with memory. You drift closer, and for the first time in your long journey, you feel something like melancholy. Not sadness exactly, just awareness. This galaxy has lived a full life, born from collisions, enriched by supernovae, sculpted by winds and magnetism. Now it settles into peace. Its black hole naps in the center, occasionally flickering with a lazy jet. The galactic weather has calmed, the chemical storms have quieted. What remains is equilibrium. Here's your historical anchor. In the early 2000s, surveys like the Sloan Digital Sky Survey began classifying millions of galaxies by color. Astronomers found that they tend to fall into two main groups: the blue cloud, filled with star-forming galaxies, and the red sequence, where older, inactive galaxies reside. Between them lies the Green Valley, a transitional phase where galaxies shut down their stellar factories. The universe, it seems, goes grey before it goes red. You pass through such a Green Valley galaxy now. Its spectrum is caught mid-fade, a mix of blue and gold that gives it a mossy hue. You can still see pockets of star formation glowing faintly in its arms, but they're small, isolated like campfires in a vast meadow at dusk. The air, if you can call interstellar space air, feels thinner, cooler. Here's your quirky tidbit. Some galaxies go through rejuvenation, a cosmic midlife crisis of sorts. A minor merger or an inflow of fresh gas can restart star formation, lighting them up again for a few billion years. Astronomers call this galactic frosting, because the new stars are a thin, bright layer atop an old, steady cake. You can't help but smile. Even galaxies, it seems, sometimes refuse to act their age. Historians and cosmologists still argue about what causes galaxies to truly quench. Is it the black hole at their core heating and expelling gas? The gradual starvation as inflows from the cosmic web slow down? Or perhaps the exhaustion of raw material after trillions of stellar births? The answer is likely all of them, working together in a slow collaboration of inevitability. You glide through the outskirts of an aging elliptical galaxy, and the light here feels ancient, soft orange, nearly sepia. Billions of small red stars flicker quietly, steady and unhurried. There's no gas left to form new ones. Everything is recycled, stable, predictable. The galaxy looks peaceful, but there's something eerie about it too. A museum of stars, every one a relic of brighter days. In its center, the glow of a supermassive black hole pulses faintly, surrounded by a halo of diffuse light. It doesn't feed much anymore. It simply waits, patient as time. Around it, globular clusters orbit like bees that have forgotten their hive's purpose, but still trace the pattern from habit. You feel a strange affection for them. They're the galaxy's memories, preserved in motion. You drift farther, and the quiet deepens. Clusters of galaxies, once ablaze with activity, now look subdued. There are fewer collisions, fewer supernovae, fewer newborn stars. The cosmic web still holds everything together, but the flow of material through its filaments has slowed. The universe has entered a gentle middle age, steady and content, but already hinting at the long decline ahead. And yet, it's not sad. It's serene. The colours are warmer, the light softer, the pace slower. It's as if the cosmos, having spent billions of years in fiery adolescence, has finally found calm. Even time seems to breathe differently here. You pass through a cluster core where hundreds of galaxies have gathered, bound by mutual gravity. Between them drifts hot plasma, faintly glowing in X-rays. You realize this is the afterglow of endless recycling, the byproduct of billions of stellar lifetimes, now suspended in equilibrium. It's strangely comforting, a cosmic retirement home where every galaxy has found its orbit and settled in for the long evening. But not all is still. You spot one small spiral still shining defiantly blue, its arms bright with young stars. It's an outlier, a late bloomer, perhaps fed by an unexpected stream of fresh gas. It looks almost mischievous among its quiet neighbours, like a teenager in a room full of philosophers. You can't help but root for it. From far above, the entire cluster glows like a lantern in fog, soft, diffuse, timeless. You realise the universe isn't fading so much as evolving into subtlety. Where once it shouted, now it whispers. Where it blazed, now it glows. It's the difference between a bonfire and candlelight, both beautiful, both warm. You take a slow turn, letting the soft red light wash over you. Somewhere in the back of your thoughts, you recognise that this is the same process that will eventually quiet your own Milky Way. Billions of years from now, its blue arms will pale, its black hole will nap, its stars will drift in slow harmony. It will rest, as all things must. Ahead, faint glimmers ripple in the dark, small galaxies swarming around their elders. They're dwarfs, the overlooked children of the cosmos, still buzzing with mysteries of their own. You smile faintly, ready to visit them next. After all, even in a universe winding down, curiosity never sleeps. You leave the calm amber light of the great galaxies behind and drift toward the outskirts of the cluster, where the view turns unexpectedly busy again. Tiny glimmers flicker at the edges of vision, small, irregular shapes darting between the massive spirals and ellipticals. At first they look like afterimages, tricks of light, but then one of them catches a ray of distant starlight and flares. You're not seeing ghosts, you're seeing dwarf galaxies, the scrappy underdogs of the cosmos. They come in all varieties, faint smudges, compact spheres, ragged lumps of stars barely clinging to one another. Some look like miniature spirals, others are more like debris clouds that never quite figured out how to grow up. You float closer to one, and it feels earnest. A few million stars, a sprinkle of gas, one loyal dark matter halo holding everything together. If galaxies had personalities, this one would be the shy overachiever, small but stubborn, quietly rewriting the rules. Historically, we didn't even know how many there were. Early telescopes simply missed them, assuming the space between large galaxies was mostly empty. But in the 1990s, astronomers began noticing faint glows in deep exposures, tiny galaxies hiding in the shadows of larger ones. By the 2020s, surveys revealed that for every grand spiral like the Milky Way, there might be dozens, even hundreds, of dwarfs orbiting nearby. Our own galaxy hosts at least 60 known companions, like a family reunion where most relatives are tiny, introverted, and slightly eccentric. You glide past one of the Milky Way's ancient companions, the Sagittarius dwarf elliptical galaxy, now slowly being shredded by gravity. Its stars are peeling away, forming tidal streams that wrap around the Milky Way like cosmic ribbons. You can actually trace the arc, billions of suns stretching across the sky, the remnants of a galaxy devoured with exquisite patience. The view is oddly moving. Even in cosmic consumption, there's grace. Here's your quirky tidbit. Some dwarf galaxies have the lowest metallicity, meaning few heavy elements, of any structures known. They are time capsules, preserving the chemistry of the early universe. Astronomers studying them sometimes joke that dwarfs are the universe's hoarders, keeping the original cosmic recipe unedited for over 13 billion years. Historians and cosmologists still argue about how these dwarfs formed. Did they arise as independent systems in the early universe, or as leftovers from larger galaxies torn apart by gravity? Some seem ancient beyond measure, their stars nearly as old as time itself. Others look like fragments, shattered pieces from collisions, kept alive by sheer persistence. The truth, maddeningly, is probably both. You drift into a cluster of these small galaxies orbiting a massive elliptical. They move like satellites, tiny lights circling a pale giant. Every so often one strays too close and gets tidally disrupted, its stars smeared into faint streams that glimmer in the dark. You realise these trails, the faint scratches on astronomical photographs, are not random noise. They are the handwriting of destruction, signatures of swallowed dwarfs written across galactic margins. You pause near one particularly luminous dwarf, the large Magellanic Cloud, a friendly neighbour to the Milky Way, still busy forming stars. You watch its bar-shaped heart rotate lazily, speckled with glowing nebulae like freckles of fire. One of them, the Tarantula Nebula, blazes so bright it could light an entire solar system. Its radiation washes over you in soft waves. You remember that when sailors in the southern hemisphere gaze up, they see this little galaxy as a smudge beside its twin, the small Magellanic Cloud, tiny reminders that even small things can shine across oceans and epochs. The Magellanic Clouds trail long streams of gas behind them, stretched thin by the Milky Way's pull. Those streams will one day merge with our galaxy, feeding it fresh fuel for new stars. Even as the big galaxies age, the little ones keep them young. It's a tender kind of dependency, giants fed by their own offspring. You float deeper into the swarm, noting how different each dwarf feels. Some are nearly spherical, calm and ancient, populated only by red dwarfs. Others are chaotic, dotted with bursts of blue from recent star formation. A few glow faintly green from ionized gas like cosmic fireflies. They're small, yes, but they make up nearly all the galaxies in the universe. If the big spirals are the main cast, the dwarfs are the chorus. Quiet, numerous, indispensable. You find yourself drawn to one dwarf on the verge of being torn apart. Its outer stars are already slipping away, curling into a halo around its larger host. You hover close, feeling the faint gravitational tension tug at your senses. It's mesmerizing, the slow unweaving of a galaxy's fabric. Each star leaves gracefully, as if aware it's becoming part of something larger. If you could pause time and chart the motion of every star here, you'd see rivers of light looping through space, tracing the history of mergers and losses across billions of years. To human eyes, these faint streams barely exist, but with patience, telescopes reveal them, evidence that galaxies, even mighty ones, are built on the sacrifice of smaller kin. You glance back toward the Milky Way's domain and imagine the faint constellations those streams might make if you could see them with naked eyes. They'd weave across the sky like glowing fingerprints, proof that our home is stitched together from countless cosmic lives. For a brief moment you wonder what it means for something to survive in cosmic terms. The dwarfs you see dissolving now will soon vanish as independent entities, yet their stars will live on, orbiting within their conqueror. Their light will blend, their histories folded into a grander story. Survival here is transformation. The space around you glows faintly with starlight scattered from those very mergers. It's a soft, diffuse radiance, the background hum of cosmic inheritance. You realize that every photon here carries the memory of two galaxies meeting, mingling, and becoming one. From far away the cluster looks serene, but you know better. Beneath the calm lies ceaseless exchange. Material traded, stars captured, dwarfs reborn as parts of something vast. It's messy and magnificent, like family history written in gravity. You linger one last moment among the dwarfs, admiring their quiet persistence. They may be small, but they're the backbone of cosmic evolution, the hidden 90% that keeps the universe interesting. Ahead, a deeper dark beckons. The faint light of ancient galaxies flickers again, but this time it feels different. The telescopes of a young species far away are just beginning to glimpse this very scene. They're looking backward, trying to understand the same stories you've drifted through. The next chapter belongs to them, to us, looking both back and forward at once. You turn toward that double horizon. The light of the past fades behind you. The promise of the future glows ahead. It's time to see how the universe, and its storytellers, learn to gaze at themselves across time. You drift through a soft darkness stitched with faint threads of light, and for the first time in this long journey, you feel as though you're being watched back. It's not an illusion. Down there, in the quiet arms of a spiral galaxy, creatures have opened their eyes to the sky. They build mirrors, lenses, machines of exquisite patience. They are looking back and looking forward. The universe has reached the age of reflection. You hover near one such planet, small, blue, unassuming. Its surface glimmers with oceans that catch the starlight like liquid mirrors. From the night side, thin beams of radio waves flicker upward, little shouts into the void. Each carries fragments of thought, curiosity, fear, sitcom reruns. You listen and smile. This is what happens when the cosmos becomes aware of itself. It starts to talk. Your historical anchor hums through the dark. December 1995, when the Hubble Space Telescope pointed at a blank patch of sky for 10 days. The resulting image, the Hubble Deep Field, revealed thousands of galaxies in an area smaller than a grain of sand held at arm's length. Humanity's sense of scale snapped, then expanded. That was the moment the universe stopped being a background and became a story. And here's your quirky tidbit. When the data first came in, some astronomers thought the deep field might be a fluke. Perhaps Hubble had accidentally captured a strange overdensity of galaxies. They quickly pointed it elsewhere. The result was the same, over and over. Every speck of nothing was full of everything. Space itself, it turned out, was chatty. Historians, philosophers and scientists still debate what it means that a species can look so far back in time that it sees the birth of galaxies. Some argue it's pure coincidence, a quirk of evolution and curiosity. Others see it as inevitable. The cosmos builds observers precisely so it can admire its own handiwork. Either way, those tiny eyes below have joined the conversation. You drift above their telescopes, Hubble, then Webb, then whatever names will follow. Each is a machine of longing, a glass time machine built on faith that light carries truth. They gaze backward billions of years, and you can feel the gentle overlap between their sight and yours. For a brief instant, your vantage and theirs are the same. The humans are seeing what you see, the ancient shimmer of galaxies forming, colliding, fading. Their wonder ripples through the vacuum like soft static. You hover near the newest observatory, mirror segments glinting gold in the cold. Webb's eye peers into deep infrared, slicing through dust, revealing the universe as it once was. You can almost sense its excitement, a silent gasp encoded in photons. It's showing them galaxies that lived and died before their own planet had cooled, and they, down there, respond with awe. You realize something delightful. The light these telescopes capture has been traveling since before the Milky Way had arms, and yet, here it is, being turned into data, processed, colored, printed, shared. The universe sent postcards billions of years ago, and only now are they being opened. You drift higher, seeing it all in context. Across countless worlds, perhaps not just that little blue one, beings are turning their gaze outward. Every act of observation changes the universe slightly, pulling its story into focus. Once, gravity ruled alone, now curiosity joins it. The galaxies below still move, still merge, still glow. Their cycles continue unbothered by the watchers. But something subtle has shifted in the grand rhythm. Awareness adds a new instrument to the cosmic orchestra, soft, questioning and bright. Here's an odd fact that seems almost poetic. The deeper we look into space, the further back in time we see. To study the early universe, we must stare across billions of years. But as the cosmos expands, those earliest photons will eventually drift beyond reach. One day, all this, every galaxy, every echo, will slip beyond the cosmic horizon. The future will grow darker not because of death, but because light itself will be too far away to find. You imagine those distant descendants far in the future, standing under a sky nearly empty of stars. They'll still have galaxies of their own, yes, but none of the ancient light from beyond. They'll think the universe is smaller, younger, more alone. The echoes you're hearing now will be silent by then. You can't decide if that's tragic or peaceful, maybe both. You glance back toward the blue planet. Down there, in classrooms and observatories, they're arguing about this very thing, about horizons, expansion, dark energy. They point their telescopes at the same heavens you've been floating through and say, "We want to know." They name galaxies after animals, flowers and breakfast foods because science, for all its rigor, is also love. You watch one of them, just one person, standing on a rooftop at midnight, looking up through city haze at a faint star. That single gaze, you realize, is the universe returning its own stare. You've travelled billions of light years only to end up here, watching the cosmos notice itself. You feel a kind of completion. Everything you've seen, birth, growth, fire, quiet, has led to this moment of reflection. It's not a conclusion, but a pause, a deep inhale before the long exhale of cosmic aging. From your vantage point, the universe now glows in both directions, backward through memory, forward through curiosity. The telescopes below reach out for the past while time ahead stretches patiently, waiting to unfold. You hover at the intersection, a witness to both. The light shifts again, softening into a gentle dusk. You sense the next transition, not into chaos or creation, but into calm. The galaxies ahead drift slower, the expansion accelerates, stretching the fabric of space ever thinner. The universe is learning to rest. You take one last glance down at the little planet of observers, still awake, still wondering. They don't know it, but they've already become part of the story you've been telling. Their questions are now stitched into the light itself, and as you turn toward the fading glow of the far future, you whisper what they've been saying all along. The simplest truth you've heard on this entire journey. It's all still so beautiful. The galaxies thin around you, stretched apart by the quiet persistence of expansion. Distances grow immeasurable, and light itself feels tired, fainter, slower, older. You've come so far that time has softened. You can almost hear it sigh between heartbeats. The universe is easing into stillness now, and you can feel it. The way the temperature drops, the way gravity's voice grows low and slow. This is the universe learning to rest. You drift through a wide, open gulf where the cosmic web has stretched into gossamer. The filaments that once carried rivers of gas are thinner now, their flow slowed to a crawl. Between them lie vast voids, true abysses of nothing, black so pure it feels velvet. You pause, letting the silence wrap around you. Even silence, you realize, has texture. In one direction, a single spiral galaxy glows like a lonely ember. Its arms are pale but graceful, moving slower than they once did. The star formation that once painted them blue has faded, replaced by a faint amber glow from old red giants. It looks peaceful, the way a candle flickers at the very end of its wick. Here's your historical anchor. In the late 1990s, astronomers studying distant supernovae discovered that the universe's expansion was accelerating. The culprit was named dark energy, a mysterious pressure embedded in the fabric of space itself. Overnight, the cosmic future changed from one of slow cooling to endless stretching. Galaxies that are neighbours now will drift beyond each other's reach. Light will keep travelling, but it will never arrive. It was the universe's ultimate plot twist, eternal expansion. You drift toward that pale spiral, watching the faint currents of gas still circulating in its halo. Most of its companion galaxies have already slipped away, pulled beyond its gravitational leash by the acceleration of space. Only a few remain, locked forever in orbit, faithful companions in an increasingly empty sea. You can almost hear them whisper to one another. Remember when we were surrounded by light? Here's your quirky tidbit. Trillions of years from now, when star formation has fully ceased, the night sky of any surviving civilization will be eerily blank. Without new stars, only red embers and the occasional supernova will pierce the dark. Some astrophysicists have joked that future astronomers will think their universe consists of just one galaxy. And they won't be wrong, at least from where they'll stand. The rest will have faded beyond visibility, carried away on a tide they can't even feel. Historians of science still argue what dark energy really is, a constant property of space-time, a dynamic field that evolves, a sign that our understanding of gravity is incomplete. The debates go on in theoretical corridors, but out here the answer feels irrelevant. Whatever it is, it's gentle. You can sense it. A faint pressure everywhere, like the soft pull of a tide you only notice when you stop trying to swim. You float above the galaxy's core and look down. The central black hole still glimmers faintly, swallowing what little gas drifts close enough. The jets that once pierced the sky are gone, replaced by a quiet ring of light, the ghost of activity. Around it, stars orbit slowly, steady as metronomes. You've never seen such poise. It's funny. You expected the universe's old age to feel lonely, but it doesn't. There's tranquility here, a sense that everything has found its place. The frantic creation of earlier epochs has given way to long, patient equilibrium. It's not an ending, it's a rest. The cosmic microwave background, once a blinding blaze, has cooled to near invisibility. Its temperature is only a fraction above absolute zero now, just enough to whisper. You close your eyes and listen. The whisper says, "I'm still here." You drift farther out, past the edges of the galaxy, where rogue stars wander the void. Some are still burning weakly, Others are frozen white dwarfs, faint cinders radiating the last of their heat. One drifts near you, its light barely perceptible, soft as breath on glass. You imagine touching it, feeling the faint warmth of memory. Every atom in that dying star has lived countless lives, fused, scattered, reformed. Perhaps some will one day condense again in another cosmic cycle, if such cycles exist. Or perhaps this is it, the final exhale before stillness. Either way, you feel no urgency to decide. The beauty lies in not knowing. You pass through the intergalactic dark, and time, if such a thing still matters, feels elastic. You could travel 1 billion years in a single heartbeat here. Space stretches, light fades, but gravity still hums softly, a reminder that not even expansion can erase connection entirely. If you look carefully, you can see faint trails where galaxies once were, the afterglow of what's been lost to distance. They're not sad exactly, more like old photographs, faded but cherished. You think of the observers you saw in the previous section, the ones who looked back and asked questions, their telescopes, their curiosity, their wonder. All of that too is part of this universe. Every act of noticing is stored somewhere in the light, echoing through the quiet. Awareness, it seems, leaves a trace that gravity can't erase. You realize then that the universe isn't vanishing, it's internalizing. All the chaos and color of its youth have condensed into memory, into the soft hum of things that once were. It's not emptiness you're floating through, it's recollection. A single star flickers far ahead, its glow red and calm. You drift toward it, letting it fill your field of vision until everything else fades away. For a brief moment, the entire universe feels contained in that one point of light. Then slowly, even that begins to dim. You smile, a slow, sleepy smile, and let it. Because this was never a story about ending. It's a story about motion, about light that kept traveling even when no one was left to see it. The galaxies may rest, but their light still hums, carrying whispers across infinity. And if you listen closely enough, quiet, still, here in the dark, you can hear it. Thank you for watching. The hum grows softer, blending into the cosmic background, into the silence you first met all those sections ago. You've come full circle, from the first darkness to this one, from potential to peace.